Alright guys, this lesson is similar to what we did yesterday. We are converting metric units though today. So we are using our ratio reasoning to convert metric measurements. So first you have the solve and discuss. If you want to take a moment and pause your video and then go ahead and then you can play again to kind of check your answers with mine and see if we agree. So go ahead and pause now. Alright, well, when I like to solve these, I like to use my conversion factors in a little dimensional analysis here. So I will set up kind of my ratios that I have my 5 liters and then my conversion factor here. My liters cancel out, so then I'm going to have 5,000 milliliters. So based off of this information here. Alright, and then if we looked at the water bottle, we have the same unit, so I don't have to change anything. I can just take my 5,000 milliliters and divide it by my 250 milliliters to get 20. So, and that's going to be, I guess, water bottles, because Sam is filling up the liter jug there. So 20 water bottles. It's wanting to also know how many liters of water does Sam's water bottle hold when full, so I can still do my dimensional analysis here. So I have my 250 milliliters I start with and use my conversion factor, and I can change that up so that I have my 1 liter on top so that my milliliters can go ahead and cancel out there, so that I'm going to end up with 0.25 liters in each of those water bottles. Alright, so as you can see, it's going to be similar to what we did yesterday, looking at this metric units. So metric units are usually by a base of 10, as you can kind of see from this little example chart here. So we'll go ahead and dive into our first example. Alright, here's our first example here. We have Amelia is helping her father build a skate ramp. They cut a board 1.2 meters long to use as the back of the ramp. Is the length of the board as shown in centimeters correct? So we want to convert. So we're looking at meters to centimeters. So if I look over here at my kind of conversion factor chart, I have my centimeters and meter here. I'm going to start with my 1.2 meters. Set up my conversion factor here. My meters need to cancel out, so I have my 1 meter down in the denominator and my 100 centimeters up here so that my meters cancel. And then if I multiply straight across here, I'm going to get 120 centimeters. So is she correct? Yes, she has the correct length, saying that that's 120 centimeters. Alright, here's another one, guys. Go ahead and try this one on your own. Pause the video and then check back with me in just a moment. Alright, so here's your try it here. So we're trying to determine if the board is wide enough. So we're looking at decimeters to meters. So I use my conversion factor right here to determine that the board is 2.35 meters, but is not wide enough for what they need for their skate ramp. And then they convinced me and asked if we converted our decimeters to meters, can we do meters to decimeters? And yes, we can do that, and I did right here. So I got 25 decimeters, but the board is still not wide enough. So no matter which way you kind of converted it, you're still going to come to the same conclusion. Alright, so here we go again. We're going to look at example 2. So we have Raj poured 150 liters of water into a aquarium. How much more does Raj need to fill the aquarium? Alright, so let's kind of see what we have here. So we have our liters and we have hectoliters. So I think I'm going to want to use this conversion factor right here to help me determine that. Okay, so I'm going to want to change my hectoliters to liters so that I can compare that way. So I have 2.2, and I'm going to use my conversion factor here. So I have 100 liters. I want my hectoliters to cancel, and there's only one of those. All right, so go ahead and cancel out my units. So I'm just left with my liters here. I'm going to have 2.2 times 100, which is going to give me 220 liters. All right, so this is how many liters are in there. The capacity of the aquarium is 220 liters, and he's only poured in 150. So we want to take our 220 minus our 150 to determine that he will need 70 more liters of water to fill the aquarium. Okay, so that one kind of had two steps here. So we had to make sure that we put the units so that the units were the same, and then determine how much was left. All right, and then example 3, convert a metric units of mass. All right, so Lyle has a bowl that contains 0.8 kilograms of salt. He uses a spoon to remove 850 centigrams of salt. How much salt in centigrams remains? All right, so we're looking here for grams and centigrams. Oh, here it is. All right, so that's my conversion factor that I want to use to determine my answer. All right, but let's see. We also have to do, because we have centigrams, that's what we need, but we're at a kilogram. So we actually have to do a couple of things. So I also have to look at my kilograms to grams. All right. So first let's go ahead and do some conversion here. All right, so there's a couple of things that we can do. So I can look at my 1 kilogram is equal to my 1,000 grams. But I can also look at my centigrams here and make a conversion factor of that. So like my 1 gram here and my 100 centigrams there. And cross off my grams. So now I have 1,000 times 100, so which is going to give me 100,000 centigrams is equal to 1 kilogram. So I kind of made my own conversion factor here. So now let's convert what we have here. We have our centigrams. That's what we want our answer to be in centigrams. So we're going to take 0.8 kilograms, use my new conversion factor here. And 100,000 centigrams. All right, so our kilograms go away, and we're left with 80,000 centigrams. And then it also, the question's asking, he uses a spoon to remove 850 centigrams of salt, and how many are left. So I'm going to take my 80,000 and minus that 850 centigrams to get 79,150 centigrams of salt left. This one had a few steps. So first step that we did, we kind of went back and we just made our own conversion factor, since there wasn't a direct line over here in our kind of little table of conversion factors, and then use that conversion factor that we created to get where we wanted to be. There's a try it, guys. You can go ahead, pause your video and try it. All right, so using the conversion factor here of 100 centiliters to 1 liter, we got that 0.25 liters is 25 centiliters. So if I have all three of these, add them up to get, oops, I wrote that wrong, my 54.5 centiliters. Okay, so next thing, guys, here's your key concept, and then here's your do you understand. Go ahead and answer your do you understand. All right, so how can you use ratios to convert metric units of measure? So we want to find those conversion factors that matches the units needed, and then use dimensional analysis. And then which one is greater, and it says justify your reasoning. So I showed my work here looking at my conversion factor, but they are equivalent. Okay, rate your understanding, guys, and then you can start working on your homework.